said, I mean, if one looks at all the arguments in favour of moving to high-capacity transport, one of the most forceful is that it is a way of decarbonising freight transport. And so what I'm going to try and do in the next 15 minutes is present you with some data and some arguments to support that point. Might be worthwhile, if I can move it on, to say a few things about carbon emissions from freight transport. If one looks at the latest ITF Transport Outlook report and also looks at data on total global CO2 emissions, you can find that in 2015, freight transport worldwide, all transport modes, accounted for about 8.8% of greenhouse gas emissions. The ITF report also projected forward to 2050, suggesting that on a business as usual basis, by 2050, freight might account for about 5.7 billion tonnes of CO2. If one looks at the latest IPCC assessment report from 2014, it suggests if we want to stay within the 2-degree temperature rise by 2100, then all man-made emissions of CO2 will have to be limited to 20 billion. In other words, if nothing is done about freight alone by 2050 could be 29% of our allowable emissions. So clearly we will be requiring deep reductions in the carbon intensity of freight. We don't as yet have a global target for cutting emissions from freight transport. There is an initiative underway, the Science Based Target Initiative, to which about 200 companies have so far subscribed, which is currently consulting on what would be a realistic target for cutting carbon emissions from freight. Here in Europe, however, the 2011 White Paper on Transport set targets for decarbonising transport. Now, if the freight sector is to meet those targets at an EU level, then that will require an 80% reduction in the carbon intensity of freight transport between 1990 and 2050. And that is going to be a very tough challenge to meet. So that's the background, in a sense, to what we're talking about in this session. Those of you who work in this area will know that there are various analytical frameworks that you can apply to try to determine how you decarbonise freight transport. The one that we tend to use is the one on the right there, which we call the Green Logistics Framework, which suggests there are 5 things you can do to decarbonise freight transport. You can reduce transport intensity, just reducing demand for freight transport. You can shift transport mode, you can improve vehicle load factors, you can improve energy efficiency, or you can switch to lower carbon transport modes. Now, what we're talking about this afternoon, high capacity transport, really relates to 2 of those, improving vehicle load factors and also improving overall energy efficiency. The latest figures I've seen for Europe suggest that only about 4% of road ton kilometres moved by high capacity transport in longer and heavier vehicles. So there's a big potential to increase that figure. Some years ago, I developed an analytical framework that you can use for assessing the costs and benefits of increasing the maximum size and weight of trucks. It's a rather complicated framework. Thankfully, this afternoon, I'm just focusing on one box in that framework in the top left-hand corner, just looking at CO2 emissions. So I'm not saying anything about other pollutants, about safety, about risk, and so forth. So what could the contribution of high-capacity transport then be to the decarbonisation of road freight? There are various companies make claims. A trucking company in the UK that's developed a longer, heavier vehicle claimed you can cut your CO2 emissions by between 8 and 16%. There have been larger scale trials in the Netherlands and in Germany, and they have been very positive. I've extracted some quotations from the relevant reports. In the case of the Netherlands, for example, they said that for road transport, this is an important innovation in the effort to reduce CO2 emissions. And then more recently, as I'm sure many of you will be aware, the German government has approved gigaliners, longer and heavier vehicles for general operation in Germany. And the study done by BST, again, partly justified that decision on the basis of the carbon reductions that can be achieved. The International Road Transport Union, in its report recently on the commercial vehicle of the future, makes some projections about the extent to which high-capacity transport can cut carbon emissions in the European road freight sector. So they reckon that by 2030, HCT could achieve about a 3.5% reduction in CO2 emissions, and potentially by 2050 a 7.5% reduction in CO2 emissions. Not huge, but nevertheless a significant contribution. And then in the UK, research centre that I was involved in, and David Sabon, the director of the centre, is here, did a project for the Committee on Climate Change in the UK, looking at all the ways of decarbonising road freight transport in Britain up to 2035. And they reckon that by the early 2030s, up to about a quarter of the carbon savings would come from the use of longer and heavier vehicles. So a lot of evidence to suggest that this is a very positive way of decarbonising freight transport. Now, if we simply focus on the vehicles, things are relatively simple. I'm going to be talking mainly about the 25-metre longer, heavier vehicle with a carrying capacity of 50 or up to 60 tonnes. That would give you a 3-for-2 substitution. We can replace 3 trucks with 2, and that translates into greater load consolidation and improved energy efficiency per tonne kilometre. If one reviews the literature in this area, again, there have been studies done in various countries, you can see that that would save between 10 and 20% of fuel consumed and also of CO2. It partly varies because different countries and different studies have used different maximum weight figures for these vehicles. So it's very hard to compare much of the data on the public domain because different methodologies were used, the geographical areas differ, some of the assumptions made about price elasticity. So it's hard to make an overall conclusion. But the other challenge is moving from a vehicle-based perspective to a system-wide perspective. If you allow this at a country level, what would be the macro-level impact? Why is that difficult? Partly because of the diversity of longer and heavier vehicles. Very heterogeneous set of possible vehicle configurations. The other problem is that the freight varies a lot. One of the key determinants of the carbon benefits you get is the density of the freight that's being moved and how that relates to the size and the weight restrictions as well. Again, interesting work has been done in this area, partly in connection with the last OECD study on this subject, which was published back in 2009, where they looked at 39 different configurations of truck. Some of them the standard workhorse vehicle at the time, others high capacity or even very high capacity vehicles. John Woodruff, who will be speaking in a few moments, was one of the contributors to that study. They also came up with a nice metric. It was a composite measure of freight density that took account of both the cube as well as the weight. So this graph shows the energy efficiency of these different vehicles, and the capacity of the vehicle increases as you move from left to right, and it shows quite clearly that the higher capacity vehicles deliver greater energy efficiency and reduce carbon emissions per tonne kilometre. And the other problem you have in going from a vehicle perspective to a system perspective is the geography, because it's generally accepted that these longer and heavier vehicles will move on a more restricted road network. And there's a possibility therefore that the journeys that these vehicles will make will be more circuitous. So if there are additional vehicle kilometres to be run, then that will partly erode some of the carbon benefits. So therefore we have to look at the issue of network access, which I think Chris will be addressing in his presentation later. Then pulling back further, in going to the system, we have to look at the freight market and the level of adoption of these vehicles and also their impact on freight modal split. Because, as I'm sure you're all well aware, these vehicles will make the movement of freight by road cheaper. It will improve its competitiveness and therefore can divert freight from other lower carbon transport modes like rail or water. I was involved in a study in the UK that looked into longer, heavier vehicles back in 2007, 2008. And we did a lot of modelling at that stage of the impact of longer and heavier vehicles on the freight modal split in the UK, mainly between road and rail. And the results of that analysis depend very much on the elasticity values, the cross-modal price elasticity values factored into the model. But there's no denying that there will be some erosion of freight traffic from alternative modes. Whether it will be as bad as the railway sector would like us to think is another matter. Clearly, there's been a lot of lobbying against high-capacity transport by people on the railway side. I'm sympathetic to many of those arguments, but my feeling is that people have been exaggerating the cross-modal elasticities, and that this will not be as damaging to rail as people project. It's also been argued if we make road freight cheaper, companies will make more use of it. They will reconfigure their supply chains, and they will lengthen the distance the freight moves, and that will generate more ton kilometres. Again, the available evidence on that suggests that is unlikely to happen. But critical to all of this are the elasticity values that you factor into the models. In connection with the project that Jirka mentioned, we ran a workshop in Cambridge back in December where we focused specifically on these elasticity values. They vary a lot by freight market, by country, by sector, and so it's very difficult really to generalize. But I do flag this up as one of the controversial issues in the decarbonisation of freight transport. This conflict between, on the one hand, trying to improve the efficiency and the carbon efficiency of road freight, and on the other hand, trying to shift more freight onto alternative modes. These two things are in conflict, and it would be nice if we could find a way of reconciling that. And then pulling back further, one has to look at how supply chains, logistics systems will adapt to the use of high-capacity transport, because that will influence the uptake of these vehicles, the extent to which loads migrate from the existing vehicles to these longer and heavier ones. It will also relate to the capacity utilization, because a lot of the models here assume that the trucks will be full on every kilometre they run, and clearly that is not the case. So again, we've got to have realistic assumptions about how well that extra capacity will actually be used. Anyway, if you factor all that together, there are a few studies I came across which have tried to look at the effect of high-capacity transport on freight transport CO2 emissions as a whole. Again, the results vary. For the reasons I've mentioned earlier, because the studies were done in different countries using different methodologies. Overall, it suggests you can get between a 2 and a 6% reduction in your CO2 emissions by moving to high-capacity transport. So just to conclude with a few general points, if you simply focus on the vehicles and the vehicle substitutions, you can be getting a 10 to 20% reduction in CO2 emissions per tonne kilometre. It's hard to go from the vehicle to the system level for the reasons I've mentioned, because you've got to make assumptions about adoption rates, modal shift, vehicle load factors. But on the basis of the available data, it would suggest you can get about a 2 to 6% reduction in CO2 emissions from freight transport as a whole. Just one other point I will make before I end. If you review all the studies that have been done, you can divide them into two categories. The ones that are based on theoretical modelling and simulation, and the ones which are based on real-world experience. And the latter category suggests the CO2 emissions are greater. And they're therefore, to my mind, are the more credible of the studies that have been done so far. So just to conclude overall, it seems to me that high-capacity transport can make a significant contribution to the decarbonisation of road transport and also transport in general. Thank you very much.